Okay, class, today we're going to talk about um, scientific notation. Let me go from beginning. Okay. Scientific notation is pretty much a way to write very, very large numbers. Our learning target today and probably tomorrow, I can estimate and compare very large or small numbers in scientific notation. The reason I had you review the exponent rules that we just went over is that we're going to use the exponent rules as we deal with manipulating scientific notation. But first, we need to learn what scientific notation is and why we use it. Okay, let me plug this up before it dies. Okay, scientific notation is used to denote very small and very large numbers. Now, if you're going into any kind of STEM or medical, engineering, mathematics, applied mathematics, chemistry, all of that, you're going to use scientific notation. As a matter of fact, when you take chemistry, you're going to go over this again. So hopefully you will remember this from from math 8. Okay, so for example, the mass of one gold item is that many grams. You see what the decimal is and how many zeros we have? That's a very, very small number. And who would want to write that many zeros every time you had to write the mass of a gram of a gold atom? Now here's another extremely large number. Don't ask me what that is, because once I get past a billion, I'm lost. 1 gram of hydrogen contains, that's a whole bunch of zeros, that many hydrogen atoms. So instead of writing those numbers really, really large like that, you use scientific notation to write them in a more compact form. So what does this have to do with exponents? That's what we're going to find out. So this ties right into the last lesson. Scientists can work with very large and very small numbers more easily if the numbers are written in scientific notation. Once it's in scientific notation, you can add, subtract, multiply, divide, whatever you need to do. Now, when you get into multiplication and division, that's when you use your exponent rules, okay? But addition and subtraction are pretty much the same. Okay, how to use scientific notation. In scientific notation, a number is written as the product of two, okay. Oh, I'm sorry. On the very first one, let me go back. I forgot to tell you when to write. Here at the top of your paper, scientific notation is used to express very large and very small numbers. Write that in this top one right here, very first one. You're going to need it. So it's used to express very large and very small numbers so that problem solving will be easier. So we're going to write that right up here. Y'all see it? I'm sorry, I was going too fast. Okay. So again, how to use scientific notation. In scientific notation, a number is written as the product of two numbers. Okay? So let's write this in the blank. A coefficient and 10 raised to a power. So right there. In scientific notation, this is Roman numeral 2, A. So it's going to be a coefficient and 10 raised to a power. So you're going to write that right there, a coefficient and 10 raised to a power. Those of you at home, it's Roman numeral 2 right there, A. So right there on that line, you're going to write a coefficient and 10 raised to a power. My sixth graders thought I was talking to myself till the little girl finally came to school. They were like, who are you talking to? Okay, for example, the number 4,500 is written, or 4,500 is written in scientific notation as 4.5 times 10 to the third power. So right there is where you're going to write that. So the number 4,500 is written in scientific notation as 4.5 times 10 to the third. And we're going to get into how we know to do that. Right now, we're just showing you what it looks like. So you're like, what the what right now? That's fine. Because this is the introduction to scientific notation. You know, when they get into things like bacteria, viruses, or viri, as they say, viri, they'll use scientific notation because there's so many parts per million or something like that. They'll do something like that. But they use scientific notation is used quite a bit. You've probably seen it and didn't know why it was written like that. Okay, so the coefficient is 4.5. So you want to write that where it says the coefficient is. That's on 2B. The coefficient is 4.5. So we have a coefficient and a power of 10. Earthquakes are that Richter scale. If they didn't write it in Richter and they wrote it instead, or magnitude, they would write it in scientific notation. Okay, so this is important. The coefficient must be a number, fill this out, greater than or equal to 1 and smaller than 10. So it could be 1, everything up to 9.9999999. It cannot be 10. But it has to be greater than or equal to 1, but smaller than 10. That's the most important part. You need a pencil or a pen? You say you got one? Oh, okay. I was going to get you a mechanical. I use the 0.9 and I still break the lids. Oh, y'all's grades are up to date. And remember, the date in Schoology is the date in iNow. So that's, you'll look for it in Schoology under the date I have in iNow. I want you all to get caught up. Okay. So the coefficient has to be a number greater than 1, but smaller than 10. Greater than 1, smaller than 10. What questions do you have at this point? Or are we not at the point where you have questions yet? Are we almost there? Okay. The power of 10, or the exponent in this example, before I bring it up, what is the exponent in this example? 3. So that's what you're going to write. It's 3. So the exponent tells you how many times the coefficient must be multiplied by 10 to equal the original number of 4,500. So 10 to the third power let's see, I can see this board over here. Okay, so I hope y'all can see that. 10 to the third power is 1,000 times 4.5. Oh, I'm over here. Okay, that's why I couldn't see. Okay, so 5,0,0,0,5, and then 0,0,0,4. Add everything together. Bring my decimal over 1, and I'm back to 4,500. So we see that's where we get it from. That's the thing. Now 4,500, we'd probably just write 4,500, but okay, rules to remember. If a number is greater than 10, the exponent will be positive and is equal to the number of places the decimal must be moved to the left to write the number in scientific notation. So that is C, 2C. You're going to just fill in the blank right there. So if a number is greater than 10, I know that looks confusing right now, but we're going to get to some actual numbers and it's going to make sense. So if a number is greater than 10, the exponent will be positive and is equal to the number of places the decimal must be moved to the left to write the number in scientific notation. Look at the original no, that shouldn't be 10. That should be greater than 1. Correct that for me, please. Greater than 1. Not 10. Something sounding right about this. Greater than 1. This right here should be 1. Change that on your notes to 1. And I'll change it in the PowerPoint that I put in mine. So if a number is greater than 1. In C, just change that to a 1. Change that 10 to a 1. If a number is greater than 1, the exponent will be positive and is equal to the number of places the decimal must be moved to the left to write the number in scientific notation. No, that's right. It's 10. It's 10. It's 10. Never mind. Correction, it is 10. I'm sorry. Yeah, because you got to, because 10 is 1 times 10 to the first. Yeah, it's 10. I'm sorry. So if a number is greater than 10, I'm sorry, that was my mistake, y'all. If a number is greater than 10, the exponent will be positive and is equal to the number of places the decimal must be moved to the left to write the number in scientific notation. I was thinking about the next one. Here's another rule. If a number is less than 1, the exponent will be negative and is equal to the number of spaces the decimal must be moved to the right to write the number in scientific notation. Just had a little moment where my brain blanked out. Oops. I'll get those. Okay, next. A number will have an exponent of 0 if the number is equal to or greater than 1, but less than 10. So let's say it's 9. 9 would be 9 times 10 to the first. 10 to the 0 power, which is 1. 10 to the 0 power would be 1, right? So that's our next one. A number will have an exponent of 0 if, down there, the number is equal to or greater than 1, but less than 10. But as we use these rules, they'll begin to make more sense. So here are the steps. On the next page, that's going to be F. To write a number in scientific notation, move the decimal to the right of the first non-zero number. So we want to write that in F1. Move the decimal to the right of the first non-zero number. Let's write that right here. Mm-hmm. Yeah. Mm-hmm. I didn't even know y'all knew number was hashtag. Yeah, these are your notes, so whatever, like I use different abbreviations for mine. Mm-hmm. Yeah, because I'll do, and like for with and without, that's my with. They used to have something called shorthand back in the day. Without, I use number for number sign, but I didn't know y'all knew that because y'all used to know it as hashtag. So forgive me for assuming. Second step, count how many places the decimal had to be moved. So either way, you're going to move decimals, but whether it's positive or negative is determined by which way you move it. When we finish this one, we'll take a mass break. And then if the decimal had to be moved to the right, the exponent is negative, which means if you move it to the left, then it's what? Positive, exactly. So if you move the decimal to the right, your exponent is negative. If you move it to the left, it is positive. So your exponent, your 10 to whatever power, depends on which way you move your decimal. It's the opposite of the number line. Think of it that way. So if I move my decimal this way, my exponent is negative. If I move it that way, my exponent is positive, which is opposite from the number line. Okay, we're going to pause and take a mass break. And if you're watching this video, you can stop it whenever you want. Okay, I'm doing the wrong thing here. Okay, so again, the steps are move the decimal to the right of the first non-zero number, count how many places the decimal has to be moved. If you move it to the right, your exponent is negative. If you move your decimal to the left, your exponent is positive. And to emphasize again, the exponent counts how many places you move the decimal to the left or the right. So let's look at some practice problems. And you have these in your notes. And if there's anything helpful that you need to jot by them as we work them, these are your notes. So that's up to you. So the first thing says, move the decimal to the right of the first non-zero number. So I'm going to put my decimal here. Well, no, I'm not going to put it there because my number has to be between 1 and 10. So I'm going to put it there. Okay. And I already put the answer up there. I didn't mean to do that. Okay, so then I'm going to count how many spaces I moved over. 1, 2, 3, 4. And I put it between 1 and 2 because remember, this number has to be greater than 1 and less than 10. So 1.2 is greater than 1, but it's less than 10. If I put it behind the 2, that would have been 12. That's greater than 10. So I moved it 1, 2, 3, 4 to the right. And my rules say if I move it to the right, then my exponent is what? Look at your rules you just wrote down. Negative. Okay, so let's look at this one. I need to find a number between 1 and 10. So here I go right here. And then I move my decimal 1, 2, 3 to the left. Okay. So if I move it 3 to the left, what is my, am I positive or negative?
Positive.
Positive. So it should be 1 times 10 to the third. Let's see. Yeah. I just put the answer there. Didn't mean to do that. Okay, what about this next one? So I'm going to put my decimal here because that gives me a number between 1 and 10. 1 greater than or equal to 1, but less than 10. So I move my decimal 2 places over to the right. 1, 2. And since I moved it to the right, my exponent is negative. So just remember, when you have a number smaller than 1, your exponent is going to be negative. Like if this is going to be negative, that one's going to be negative, that one's going to be negative. But if your number is greater than 10, it's going to be positive. So this would be positive, this would be positive. I can't see what that is because it's behind there. Let's see. Yeah, that one would be positive. Okay, so let's look at this one. Okay, 12 is greater than 10. So where do I need to put my decimal? In the middle? So that gives me 1.2. So I move my decimal 1 over to the left. So should my, is my exponent positive or negative? Positive. You try the next one. Where are you going to put your decimal? Tell me. To get a number between 1 and 10.
In front of the 7.
Okay, if I put in front of the 7, that'll give me 98.7. So do I need to, what else? That's bigger than 10, right? So where is that? Where do I need to put it? Somebody else? Manuel, I want a number between 1 and 10. 9.87. So put it right there. Let me make that seeable. Okay, so I move my decimal 1 to the right. So is that positive or negative? Negative. And remember, the original number was smaller than 1, so it's going to be negative. So let's double check. Okay. So So that's what we got. 596. Where am I going to put my decimal, Jeremiah? Brooke, you got it?
Like between the 5 and the 9.
Between the 5 and the 9? Okay. Oh, I just moved that out of the way. I didn't mean to do that. Okay, so I just did it. So we put it between the 5 and the 9. And then so we moved it over 1, 2 to the left. So my exponent is going to be positive. Now here, what was this? Yeah, but let me put me on Snapchat. Let's see. Okay. So I'm gonna put my decimal here. That's 1, 2, 3, 4, 5, 6, 7. And since I moved to the right, my exponent is negative. So that coefficient has to be a number that's greater than or equal. Is that hard to see for you, Manuel? 7 times 10 to the negative 7. I put my decimal here, and I moved it 1, 2, 3, 4, 5, 6, 7. Let's make sure. Okay. Now, Michael, where are you going to put your decimal here on number 8?
Behind the 1.
Behind the 1?
Yeah.
Okay. So I move my decimal 1, 2, 3, 4, 5, 6 to the left. So is my 6 negative or positive? To the left, it says positive.
Mhm.
Yeah, because remember, it's the opposite of what you think on the number line. And you just always think, if my number is less than 1, it's going to be a negative exponent. If it's greater than 10, it's going to be a positive exponent. If it's 10, it's going to be the exponent of 1. Okay, so I'm going to put my decimal right here, 1.257. That's greater than 1 and less than 10. So I moved it 1, 2, 3 to the right. So that's going to be a negative exponent. What about this one? Where would you put the decimal?
Between the 5 and the 3.
Between the 5 and the 3? Okay. What'd you say?
I think it's between the 9 and the 8.
Between the 9 and the 8?
Yeah.
What do you say?
Between the
9
9 and the 8.
and the 8? Where would you put it?
And
Those are commas. You thought it was a period. Thought it was a decimal. Between the 9 and the 8. Yeah, because if you put it between the 5 and the 3, you still got 98,765.
Oh, yeah.
Yeah, so you probably thought it was okay, so we put the decimal right here. Right here. And then that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 8 is just 8. So it's going to be 8 times 10 to the 0 power. So look over those and make sure that you understand what you're doing. Okay, this one is going the other way. It's going back the other way. So if our exponent is positive, that means I moved it to the left. So which way do I need to move it to get it back to a big old number? If I moved it to the left at first, because it's positive, basically 10 squared is 100. So I'm multiplying by 100, so I'm moving 2 to the right. So I'm going to move. If this is positive, that means originally I moved it to the left. So I'm going to take my 4.9 and I'm going to move it 1, 2 to the right. Let's look at this one. This is negative, which means I moved it to the right at first. So I need to move it back to the left. So 1, 2, 0.0375. This one, 4 to the left. 1, 2, 3, 4. Okay. This one, we're going to move it 3 to the right. 1, 2, 3. So it should be 9,460. What about this one? Am I moving it to the right or to the left? The opposite of what you did before. Right. So I'm going to move it 1 over and I get 38.7. If it's multiplied by 10 to the 0, I don't do anything because that's just a 1. And then 8.2 times 10 to the 5th, to the negative 5th. So I'm going to move it back to the left. 1, 2, 3, 4, 5. Put my dot. And notice I'm putting my little bowls, put my zeros in. Okay, so that's all for today. We're gonna bell ringer this tomorrow as a quiz. So those of you at home, I hope you're ready, because tomorrow we're gonna go straight into doing the exponent rules with scientific notation. All righty, we'll practice this some more tomorrow.